Good morning, Pre-Calculus 30. I'd just ask that you open up your note packages to the first lesson. We're going to be going over the sums and differences of functions. So this is chapter 10 that we're looking at. I can sketch, analyze, and write the equation of a function that is the sum or difference of two functions. So the words sum and difference are two things that we need to distinguish right now. Sum meaning add, difference meaning subtract. So today we are going to simply add and subtract functions. So if I have two functions, say let's call them f of x and g of x, and I want to find either the sum or the difference, I'm simply going to take f of x plus g of x. That's going to give me some new function, h of x. Down here we have another way to write it. H of x equals, in brackets, f plus g of x. Remembering that f of x or g of x are simply some sort of equation with a y equals. We can do the same thing in order to find our difference. So we can find a new function, simply calling it h of x, some function of x, equals f of x minus g of x, or h of x equals, in brackets, f minus g of x. Both of these mean the same thing. Okay, so let's apply some math here. So consider two functions. One function is f of x equals negative 4x minus 3, and our second function, g of x, equals 2x squared. Determine the equation of the function h of x equals f of x plus g of x. So we want to find our sum function. Okay. So in order to do that, I am simply going to take, with not a lot of room, my pen, if I can find it here. There we go. And say, okay, well, h of x equals my function f of x. So instead of f of x, I'm going to write negative 4x minus 3 because that is what f of x is. So negative 4x minus 3. And then I'm going to have a plus, my g of x is 2x squared. So let's just write that in a little bit of a nicer math function. Sorry, I ran out of room here. H of x equals, we're just going to go in descending order, 2x squared minus 4x minus 3. And so that's your sum. Sketch the graphs of f of x, g of x, and h of x on the same coordinate axes. So I have my axes right here. So let's get a different color. Yeah. And we want to sketch f of x and g of x first. So f of x is negative 4x minus 3. That's simply a line with my y-intercept at negative 3. So I'm going to go down 3. 1, 2, 3. And then I have a slope of negative 4, meaning down 4, 1 to the right, or up 4, 1 to the left. So let's go down 4. 1, 2, 3, 4, 1 to the right. And then I can take my line tool, let's draw a line. And extend that line. And I'm going to label it f of x. So they just want us to draw f of x and g of x onto the same axes. So we're going to do the same thing for g of x. That was our line, so let's pick up a new color. I'll put it in green. G of x equals 2x squared. Well, this is a parabola, and I know that it hasn't been shifted at all. It's simply being stretched. So that means that all your parabolas start at 0, 0, unless they'd be moved around. Now, I know that typically a parabola would go over 1, up 1, over 1, up 1, because 1 squared gives me 1. But this one's being stretched vertically by 2. So that means I'm going to go over 1, up 2. Over 1, up 2. Okay. Another way to do that would be to plug this into your calculator and get your points on it. So we're just going to draw g of x off those 3 points. It's a parabola. That's not a parabola. There we go. And then they simply want us to take our last one and graph h of x. Now, h of x is a little bit of an uglier parabola, so because I know that it's 2x squared. So I can do one of two ways. I can either set up an axis, x and y, pick some points for x, find my points for y by subbing them in, and then graph it. Or I can let my calculator do the work here, plug it in, and get some points for x and y. So I'd ask you guys to plug that in, get some points for x and y, and then we can sketch our h of x on there in a third color. Okay, so when I plug this in, I'm going to pull out some x points here. I'm going to take an x point from -2, an x of -1, an x of 0, an x of 1, and an x of 2. And my y points there are 13, 3, -3, -5, and 3. So let's plot those on there, and then we're going to talk about those points. So for our h of x, our first point is at -2, 13. Unfortunately, I can't put that on my graph. So we're going to go to -1, 3. 1, 2, 3. And then we're going to go to 0 and -3. And then we're going to go to 1 and -5. 1, 2, 3, 4. That's not right. 1, 2, 3, 4, 5. That's my vertex there. And then 2 and 3. 1, 2, 3. So we wound up, we could see that we wound up with a parabola, which is what we predicted, because this is a 2x squared function. So since it's a squared, we predicted a parabola. So that's our new function h of x. Now one thing I want to look at here, guys, is if we take a look at our y values, we can notice something that kind of pops out. So my y value when x is -2. So if x is -2, 1, 2, okay, notice that my y value here is not what I expected. When x is -2, my y value here is 2. Oh, never mind, guys. That didn't work out. Of course, I'm recording this. Let's talk about a different point. So, when x is 0, okay, let's take 0 because I have 2 points on that. So when x is 0 here, my y value is 0. Well, when x on my f of x function is 0, my y value is 3. Well, my 2 points wind up adding together, and I take 0 plus 3, and I can get my y value on h of x. That's going to happen every single time. Here, we could see that my y value on g of x is positive 2. My y value on f of x is negative 1, 2, 3, 4, 5, 6, 7. So when I take that -7 and add the 2 for my g of x, I wind up at -5. So each one of these y values are going to add to your f of x plus g of x value. So, which makes sense because your h of x represents your y on your h of x graph, equals your f of x, because that's your y on your f of x graph, plus your g of x, and that's your y on your g of x graph. So let's state the domain and range of h of x. Well, let's start out with our domain. It's a parabola, so that means x can be anything. X can be the element of the reals, and I'm just doing shorthand here. Range, it's a parabola with a minimum, so that means y has to be bigger than or equal to -5, and in there it can be an element of all the reals. And they just asked for h of x, they didn't ask for f of x there. And finally, determine the values of f of x, g of x, and h of x when x equals -2. So I'm going to extend my page here. Just a reminder, I'm going to put our functions on. So we had our f of x equals -4x minus 3. Our g of x equals 2x squared. And our h of x equals 2x squared minus 4x minus 3. Okay, so they want us to evaluate at these points. There's two ways we can do that. The first thing we can do is we can go, okay, well, when x equals -2 on my graph, 1, 2, y is 1, 2 on my f of x graph. So in other words, they're saying when x equals this, what's your y value? So we predict our y value here to be 5, or sorry, 2. But let's check that. So -4 times a -2 minus a 3. So -4 times -2 gives me a positive 8 minus 3, which gives me a 5. This is what was throwing me off before. I don't know why I get 5. I must have drawn something wrong on here. 4 and 1. 1, 2, 3. So when x is -2, 1, 2, 1, 2, 3, 4, 5. My lines just must be off. So your y value on that graph when x equals -2 should be 5. So now we can evaluate our g of x equals 2. Plug in that -2 for x. 2 times -2 squared. Well, that's 2 times 2 times 2 is 8. Now for the h of x, I can do one of two things. I can either plug in my -2 for x and solve, or I could even say h of x is f of x plus g of x. So I could just take my 2 points and say, well, f of x when x equals 2, my h of -2 is going to be my f of -2 plus my g of -2. Well, my f of -2 is 5. We already found that. Plus my g of -2 is 8. We also found that. So I could take 5 plus 8 and get 13. We also could see that on our graph, when x equals -2 on h of x, y equals 13, which is, again, what we predicted. I just screwed up my f of x graph somehow. Okay. Let's consider a few more functions. Consider the functions f of x equals the absolute value of x and g of x equals x minus 5. Determine the equation of the function h of x equals f minus g of x. So remember, this is a way of writing h of x equals f of x minus g of x. So I could just plug in my functions here. F of x is the absolute value of x minus, now I'm going to put that x minus 5 in brackets for my g of x, because I need to remember to distribute that negative. So h of x is actually the absolute value of x minus x plus 5. Okay, now our next question is the f minus g of x, what we found, equal to the g minus f of x. Well, let's talk about the g minus f of x. G of x is x minus 5 minus f of x is the absolute value of x. So if I rewrite that so it's in a similar form of our f minus g of x, I could say negative absolute value of x plus x minus 5. Well, I could see that if I pull a negative out of all of them, I wind up with absolute value of x minus x plus 5. This is what we had before. So no, they're not equal. In fact, one is the negative of the other, which makes sense because we're going to happen to have a reflection on our negative f of x. So the similarities, you wind up with the same values. The differences, one is the negative of the other. Our last thing we're going to talk about here is graphing. Given a graph, find the value. Okay, so they want us to sketch the graph of m of x being simply the same as h of x. Are differences of functions, f minus g of x. So given f of x and g of x, find this value. So now here we did the same thing, but they were giving us equations. Now they're giving us a graph and saying find it. So the first way we're going to talk about this is I can add my y values. We briefly talked about this before, but what I need to know is my y values of each of my functions first. So I'm going to evaluate my functions here. When f of x is our blue graph, so I'm going to work in blue. When x is negative 3, 1, 2, 3, y is negative 2. So we're going to go through and read all of these off. When x is negative 2, y is negative 1. Okay, and then so on and so forth. So we get 0, 1, 2, 3, 4. Now for g of x, our red graph, we read the same thing except we use our red graph to read. So when x is negative 3, 1, 2, 3, our y value is 0. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Now in order to find our h of x values, since we're finding the h of f minus, sorry, not h of x, m of x. Since we're finding our m of x values, f minus g of x, we simply take our y value on f of x minus our g value, our y value on g of x. So when I take negative 2 minus a 0, I wind up with negative 2. Negative 1 minus a negative 1, I wind up with negative 1 plus 1, which gives me 0. 0 minus a negative 2 gives me 2. 1 minus a negative 3 gives me 4. 2 minus a negative 4 gives me 6. 3 minus a negative 5 gives me 8. And 4 minus a negative 6 gives me 10. So now I can graph this h of x graph. I'm going to completely ignore my f of x and g of x and just say when x is negative 3, y is negative 2 for h of x. So 1, 2, 3, y is negative 2. When x is negative 2, y is 0. When x is negative 1, y is 2. When x is 0, y is 4. When x is 1, y is 6. And I've run out of room. So we can see that this formed a nice straight line, so I'm going to take my line tool again. Draw a line through it. And we're going to label that h of x. So in order to redraw a third graph based on the fact that you have two graphs already, you simply have to take your x values, find your corresponding y values, and then add or subtract them together depending on what they ask you to do. Now there is a second way for us to do this, and that is through determining the equation. Tends not to be a student favorite, however a teacher favorite. So what we need to do this is, the first thing we're going to do is find what's our equation for f of x, what's our equation for g of x, create an equation for m of x, and then graph that. Now when there are lines like this, it's actually quite simple, right? So f of x equals, well, my y-intercept is 1, so I know I'm going to have a plus 1 on the end. And my slope is over 1, up 1, so it's going to be 1x plus 1 or x plus 1. Remembering this comes from y equals mx plus b. So now for g of x, my y-intercept is 1 to negative 3. And my slope is down 1, 1 to the right, so it's going to be negative x minus 3. Y equals mx plus b. So now to find m of x, we simply take f of x minus g of x to get our two functions. So x plus 1 minus, remembering to put the second one in brackets when it's subtraction, negative x plus, minus 3 distribute your negative. So we wind up with x plus 1 plus x plus 3. When I correspond those, I wind up with 2x plus 4. This I can graph. My y-intercept is at 4, up 2 over 1, and for good measure, down to 1 to the left. And then I can draw my line. Let's use this guy. And you will see that that gives you exactly the same thing you had before. So this is h of x. Both methods are totally acceptable. Personally, I wouldn't use this method unless it was easy for me to distinguish the equations. If they're a little bit tough to see, then it's easier to figure out just your y values and add them together. So if you're working with anything other than lines, I'd probably go with the first method. Okay. All right, if there are no questions, here's your homework. I will be back on Monday when we pick up the rest of this unit.